Welcome AFDA students, and this is video lesson 18. We're going to be doing more with domain and range of functions today, along with identifying their families of functions. So something that you're somewhat familiar with and then something a little bit newer. So we want to be able to identify domain and range of various views of functions and identify their families. Sometimes referred to as their parent function, but terminology is a function notation, f of x, you guys know those things. Domain, range, and something that you may or may not heard about or haven't seen in a while, something called interval notation. And let's discuss a little bit about domain and range a little bit more. What is domain and range? Well, you guys know that domain is your set of all x values or inputs, and range is your y values or your outputs. And there are other ways you can give terminology with those. Let's take a look at example 1. It says, what is the range of this relation? Hopefully you can see this. You may have to zoom in. There's several points here. There's a point there, a point there, a point right there, and a point there. So there's 4 points on here. So when it mentions the word range, I want you to think about y values. So a couple different ways you could tackle this problem. You could come down here and talk about the ordered pairs here and go ahead and identify those. The first ordered pair we have here is -3, 0. This next point up here is at -2, +4. This point is at 0, -4. And our last point is over here at 3, 2. So again, if we're talking about range, we're talking about all the y values here. So we can look at the y values, which would be that number, that number, that number, and that number. So let's look for those over here in our answer set. We have some set notation. And notice that they have some different ways of writing it. They're talking about x values there with x's. We know that range is a y, so that one's no good. Let me grab a red pen here for that. That's no good. This is 3, -2, 0, and 3. Those are the x values, so those aren't it. Now we're talking, we got a y here. Is all these between 4 and -4? Are all those values there? Well, there's some values that aren't included, but again, I think this choice right here, so we're going to say that's not good. But notice that the order is different, but choice D is going to be our best choice to select on a problem like that. Again, a refresher that domain is, you got to think about x's, and range, you got to think about y's. Keep that in the back of your mind here as we progress through the lesson. Let me slide down here. And let's look at some of these graphs and discuss some of this that we're talking about. Let me clear this out of the way. Oh, try to. Sorry about that. So let's look at this graph. I'm not sure if we've graphed anything like that before. But again, is this guy a function? Well, no, this is not a function. It fails the vertical line test. We could still talk about its domain and range, though, if you wanted to. Now again, think about domain as your x values. And this graph is made up of infinite number of points. It's got points everywhere on here, all over this thing. And so we have infinite number of x and y combinations here. But notice something that I'm going to do here for you guys is I'm going to talk about the x values and maybe shade right along here on the x-axis. So I think all these points are going to be between that x value and that x value. So that is how I'm going to try to write this for you guys to understand. So right over here, the smallest x value we'd have is -3. The biggest x value for any of these points that we'd have would be +3. And all the x's lie between there. So I'm going to use inequalities maybe here to say that this x is going to be bigger than or equal to the -3, but it's also going to be less than or possibly equal to the +3. So let's talk about range or our y values here. So let me grab another highlighter color. That one will work. And again, we're talking about y values here. The smallest y is right down there, but it goes up all the way to there. So how would we represent the range here? In this case, since there's, again, multiple values here, let's go ahead and grab the pen. The smallest y value we'd have would be way down here at negative 1, 2, 3, 4. The biggest y value would be up here at 1, 2, 3, 4. That would be that point, right? No, that's 1, 2, 3. Excuse me, 1, 2, 3. So way up here at positive 3. And again, we're talking about y values that could be less than or equal to that 3, but greater than or equal to the negative 4. So that's where all my y values are. Does that work for everybody? That's just the way I sort of think about it and visualize it. Let's look at this function right here. And yes, it is a function. Right? That's an absolute value function if you remember graphing some of those things. So again, domain, we're thinking about x values. So if we start tracking here our x values real quick. Again, we're thinking values that could be, this guy has infinite number of points, but maybe this, smallest one is like way over here. It goes on forever and ever that way along the x's. So if we're tracking this graph along that way, it goes forever that way. And the x values, let's say, start here at 0, and they go that way forever and ever. So it looks like right now, the x values just keep going in that direction both ways, forever and ever, all along there. So the way we represent that is we could say the phrase all real numbers, but we could just put a fancy looking R there with theta on there and talk about that being all real numbers. Now, let's talk about the range. Again, we're talking about y values here. Let me grab a highlighter. And this is a little bit different. It doesn't go on forever. The lowest y value is right there. And then the y's, as this starts going up, the y values start going up. So I'm going to say that the y's start right about there, and they start going up that way, and they start there, and they start going up that way. So the y's start way down here at what? That looks like about negative 5. Okay? So we're talking about the y's, that they're going to be bigger than or equal to negative 5. There's nothing smaller than the negative 5, so those are all that's your range or your y values there. Sort of got the game? Let's look at this one. Is this a function? Yeah, that's a function. You've graphed that. That passes the vertical line test. How about the domain, or your x values here again? Your domain, x's, this could be a x right there at 0, 1, 2. They have to switch here. 3, 4, 5, 6, 7, 8. X's go on forever in that direction, and they go on forever in that direction. So those, I'm going to say again, are going to be all real numbers. I'm going to put a fancy R there. Likewise, let's talk about your y values. It's negative 2 there, and all of a sudden it keeps on along this line right here. They keep on getting smaller and smaller. Here, if we work this way, those y's keep on getting bigger and bigger forever and ever. So again, if we were going to graph this guy right here, those y's go on forever and ever in that direction. Let me make that a different color here, make that consistent. So they go in that direction forever and ever. My x's go in that direction forever and ever. So again, the y value here is going to be all real numbers. So both of them are all real numbers. Okay? Now, to maybe talk about this or make this these functions a little bit more identifiable, let's go to the right side of our notes. Class, I'm sorry that this is a little bit small, but check over here, right here at these graphs over here. You might have to look at those either on your computer or if you print those out. I think you can see you might have to zoom in just a hair on those. But this has a picture of a graph similar to what we just did. That was a line. That parent function or its family is called a linear function, and it typically has the form y is equal to x. You don't really have to know that piece right there. You recognize this one right here, that parent function. That's called an absolute value function, and it's sort of in the form y is equal to absolute value of x. Sort of getting the deal. This guy's quadratic. We don't need this. It says y is equal to x squared right there, and that makes that U shape you're familiar with. Now probably this one you haven't graphed. The x is underneath the square root symbol, so that's called a square root. It makes a graph like that. This guy's a cubit. Make sure that snake graph. And this is a constant function. Now constant means something like if you graph this, I don't know what that would be, like that graph, if you graph y is equal to 2. 2 is a constant. So it says to identify the parent function or its family, okay, graph the function on your Desmos calculator. That's one easy way to match the graphs up. They have certain characteristics, if you will. Or you can just look at the x value right here. So that x right there has x to an exponent of 1, and it makes a line. So that's a linear function. X to the second power right here, that's a quadratic. I'm going to abbreviate that. X to the third power, that makes a cubic. You can come over here and the x is in absolute value brackets, and that's an absolute value, I'm going to abbreviate again, function. Now, square root constant. So these are not all of them, but those are a good cross-section or something that we'll be visiting here in this class right now. Now notice here with domain and range, that's different than what we wrote before. This is something called interval notation. So let's take a peek at what interval notation is. Now, interval notation, what we have to do is maybe go back and peek at inequalities that we did before. If you had this number line here with an open dot shading that way, you would have probably written x is greater than 4. But interval notation is sort of a shorthand way of writing these inequalities. It's telling you that it's going to have an open, this guy indicates like an open dot, on the 4, and it's going to go in that direction to the infinity symbol. Okay? Let's look at this one. It's a solid dot. Hopefully you can see that. A solid dot right there on 1, and it's shading to the left. So notice my bracket here, that I have this bracket, and that's a lot of times will go with this inequality symbol, where that one up there might go less than or greater than, a lot of times if you're thinking that way. So notice that it's going to start there, so we include the 1 with that bracket. That includes it, and it goes to infinity in the negative direction. That's what that's indicating. Now, if you have values that are between some numbers with this notation, you could go ahead, we would have represented that x is greater than 2, but it's less than or equal to 4, solid dot, that's why we have that inequality. But notice that the interval notation shrinks that way down and says, again, open dot there with the 2, starting there with the open dot the 2, and ending with a closed dot at the 4. That's including that. Okay? So sometimes you see that notation as you're working with domain and range. So again, the domain is x values. That's real easy. Range, we just flip that up right there and talk about those. So let's do one more of these, and let's work with some interval notation. First of all, is this a function? Yes, it is. What family does it come from? Well, hopefully you can identify that just by the graph. That's from a quadratic. Okay? Now let's talk about the domain, and let's write it in an interval notation. Again, the domain we're talking about here are x values, so we might use the same thing that we did before and talk about, you know, it has infinite number of x values. We could start here at 0, and those x values start going that way slowly forever and ever. We could start here at 0, and these x values for these points start working in this direction forever and ever. Okay? So again, if we are going to write that like we did before, we'd maybe write down all real numbers, something like that. But now we can talk about maybe from negative infinity all the way, that's a negative sign there, to positive infinity. and interval notation. Now, let's talk about the, excuse me, the range, which is our y values. Looks like they start right about here. Everybody agree down there at -2? And they start going up from there. So if I was just going to draw on the y-axis to represent those values, that's what I'd have there. Now, so we could write that as we did before, but again, let's write this in interval notation, where we're going to maybe, well, let's write it down like we would before, like y is going to be greater than or equal to -2. Interval notation say that we would start and include -2, and we'd go all the way up to positive infinity. So infinity keeps on going, it doesn't terminate, so we don't give it that bracket, it just keeps on going forever and ever. Okay? So hopefully what you've learned today is a little bit more about domain and range. I learned about families of functions a little bit today, and see the different views, different families, different parent functions that we have, and you learned about interval notation. Thank you all for watching.